Welcome my dear students to another video of class 11th chemistry. I hope whatever things we had discussed in our previous video is clear to all of you. Today in this video we will study some of the basic terms which we use throughout our studies in 11th as well as 12th. In our last video we had learned about scientific notation. So same way here also we will study some terms which are very important and considered as a basic term for studying chemistry. So let's start. Yes. Our first topic today is significant figures. We know that there may be two possibilities for an experimental value to come out as a wrong. That is, first one, the possible error made by the observer, I mean the one who is conducting the experiment, and the second one is the limitation of the apparatus. Okay, these two possibilities are there if there is an error in the experimental value. So this uncertainty can be overcome by significant figures. So let us see what is significant figure. A significant figure is the certainty as well as uncertainty of the numbers. Okay, so the number which is denoted, the number which is placed before the decimal is considered as the certain numbers, and the number which is placed after the decimal is considered as uncertain. Okay, to study significant figures we have to follow some rules. Let us see what are the rules. Rule number 1. Rule number 1 is all non-zero numbers are significant. Okay? All non-zero numbers are significant. All non-zero numbers are significant. That means what? For example, if you write 2.483, how many significant figures are there? We have 1, 2, 3, 4. 4 significant figures. If you are writing 1, 2, 3.4, how many significant figures? Here also we have 4 significant figures. If you are writing 1.23, how many significant figures? 3 significant figures. So first rule is all non-zero numbers are significant. Now the second rule. Second rule is zeros between a non-zero numbers. Between the non-zero numbers are significant. Okay? Zeros between non-zero numbers are significant. Okay? So the zeros between non-zero numbers are considered as significant. That means what? If a number is there 1.002, how many significant figures are there? We have 4 significant figures. If we have a number which is 10,001, how many significant figures are possible? 5 significant figures. If we have a number 101, how many significant figures? 3 significant figures. So the zeros between two non-zero numbers are considered as significant. Clear? Now we have the third rule. According to the third rule, the zeros preceding the non-zero number are not significant. Okay? Zeros preceding the non-zero number. Preceding means what? Which comes before. Preceding the non-zero number are not significant. Are not significant. That means what? If we have a number 0.0123, how many significant figures are there? Not 4, it is only 3. If you have a number 0.001, how many significant figures are there? We have only 1 significant figure. If you have a number 0.0001, how many significant figures? We have only 1 significant figure. That means what? zeros preceding the non-zero are not significant. Clear? Now we have the fourth one. The fourth one is also very important because you should not make mistake while writing the significant figures. What is the fourth rule? The fourth rule is that zeros at the end or after the non-zero number is significant. Okay, zeros at the end or at the right side, we can say at the right side of non-zero number are significant. So what is our fourth rule? Zeros at the end or at the right side of a non-zero number are significant. I will tell you an example. Suppose we have a question 1.00. How many significant figures are there? Here we have 3 significant figures. Okay. Suppose this question is 0.001. How many significant figures are there? We have only 1 significant figure. You can understand the difference between these two. 1.00, the zeros are on the right side and after the non-zero number. So we have 3, but it is before the non-zero number, so it is only having 1 significant figure. Is it clear? So these are the 4 basic rules of writing a significant figure. Then you may have a doubt. If there is an exponential or exponent comes, what will happen? For example, in the scientific notation, we have seen that the Avogadro number is 6.022 into 10 to the power 23. Okay. In this case, how can we count the how can we count the significant figures? We can only count the significant figures in the case of a exponential numbers. Only we will count the numerical values, not the exponent. So how many significant figures are here? We have 4 significant figures. Okay, and suppose 5.425 into 10 to the power 3. How many significant figures are here? We have 4 significant figures here. Okay, and 5425. How many significant figures? Here also we have 4 significant figures. Okay, the 5425 is also having 4 significant figures. 5.425 is into 10 to the power 3 is also having 4 significant figures. Clear? So these 4 rules along with the rule for exponential form must be in your mind while writing the significant figures. Clear, my dear students? Now we have to remember one more thing while doing calculations involving significant figures. Suppose for addition and subtraction, okay, for addition and subtraction, what you have to do is that for addition and subtraction, suppose you have 3 numbers to subtract or add. Let us see 1.234, 2.1, 5.3654. These numbers, 3 numbers are there. You have to add. When you add, you will get the values. Here it is, there is no number, so it will be 4, 5 plus 4 9, 6 plus 3 9, 3 plus 2 5 plus 1 6, 5 plus 2 7 plus 1 8. We will get the answer as 8.6994. Okay, 8.6994 is the answer. But according to significant figure rule, what you have to follow is that you have to see which number among these 3 is having lowest significant figure. We can see that this is having 4 significant figure, this is having 2 significant figure, and this is having 5 significant figures. So your answer must be according to the lowest number of significant figures, that is 2. So our answer will be 8.6 only. Clear? It is same for subtraction also. So for the addition and subtraction, we have to follow the same rule. Clear? Okay. We will follow the same rule for multiplication and division also. That means the least number of significant figures must be there in the answer also. We will write the answer along with the least number of significant figures present in the question. Clear? Okay. Now we have some rules regarding rounding off. You know that you have learned in mathematics how to round off a number. So here we have some rules related to significant figure while doing the calculation, while doing the rounding off. Let's see. Our next topic is dimensional analysis. What is dimensional analysis? Dimensional analysis means it is very frequently we have to convert units while doing the calculation. Isn't it? For example, from kilometer to meter, from meter to centimeter, or from liter to meter cube. This is very common while doing a calculation. So here we will study how do we do this conversion. This conversion is also having some theory, and that theory we call it as dimensional analysis. Okay, now let us see. I want to convert a number 50 kilometer to meter. 50 kilometer to meter. So we know that the general conversion, how can we do the general conversion? Because we know that 1 kilometer is equals to how many meter? 1 kilometer is equals to 1000 meter. So we can write 1 kilometer is equals to 1000 meter. Okay, and from this we can write 1 is equals to 1000 meter upon 1 kilometer. Okay, this is called a unit factor or conversion factor, because by the use of this conversion factor or unit factor, we will convert 50 kilometer to meter. Let's see how does. Let's see. 50 kilometer, that equals to 50 kilometer into, we will multiply the number with this conversion factor. So we will get cancel the kilometer and we will get the answer as 50 into 1000, that we can write with scientific notation as 5 into 10 to the power 4 meter. Is it clear? In your textbook we have so many questions related to the conversion using dimensional analysis. I will solve one more question here. I want to convert 2 liter to meter cube. Okay, 2 liter to meter cube. We know that 1 liter is equals to 1000 centimeter cube, and from this we can write a unit factor. What is the unit factor? That is 1000 centimeter cube upon 1 liter is the unit factor. Okay, now we can write 1 meter is equals to 100 centimeter. So what is the unit factor we can write from this? That the unit factor is, see, one thing you have to remember, here I have written 1000 upon 1 liter, but you have to remember which unit you want to delete. According to that, you have to arrange the numerator and denominator. So I will write the unit factor here as 1 meter upon 100 centimeter. Clear? Now I will do the calculation. So 2 liter I can convert as 2 liter is equals to 2 liter into the first unit factor, that is 1000 centimeter cube upon 1 liter, into the next unit factor 1 meter upon 100 centimeter, the whole cube, because we have to convert 2 liter to meter cube. Now after converting, after the conversion, liter will get cancelled and centimeter cubes will get cancelled, and from here we can write is equals to 2 into 1000, we can write 10 to the power 3 into 1 meter cube upon 100, that means 10 to the power 2 into 3, that we can write as 10 to the power 6. This will get cancelled and we have 3 here. So finally you will get the answer as 2 into 10 to the power minus 3 meter cube. Is it clear? Just have a close look on this conversion. So dear students, in this video we had covered 2 important topics. What are they? First one was significant figure, and what are the rules for writing the significant figure in writing significant figure as well as in rounding off. And the second one is dimensional analysis. How can we convert a unit factor to another one? These are very important rules or very important terms in chemistry. So if you have any doubt, please make a call or leave a message. Thank you.